recording and sharing my screen. First thing that I'd like to do is, well, the main theme of today is review. Exam 3 is due at 8 o'clock in the morning on the 23rd. I think in the syllabus it said that the exam was the 23rd. And so we'll have it due the morning of the 23rd, but we finished the content. And so we're going to review today, go over whatever questions you might have from the homework, make a kind of a quick grocery list of what we've covered this unit, and then go through one of the problem sets, one of the practice tests, so that everybody has an idea as to what to expect. The exam will be in my labs. You need to submit the work in Blackboard for credit. In terms of if you're submitting the work in Blackboard, when you take a picture of it, please try to make sure that the picture covers the entire the screen of the device you're using for the picture. A couple of people sent me some very lovely photographs, but it was so far away that I could not read your work. When I tried to zoom in to make it larger, it just became a blur. So try to make sure that your work is the lion's share of the picture. You don't have too much of your surroundings. Also, please save that picture and save your work. If there's a problem with me uploading it from Blackboard, I'll ask you to send it to me in an email. If you're using an iPhone, you're more likely to have a problem with Blackboard. If you're using an iPhone, please make sure that you are using the official Blackboard app. But before we get started reviewing, did anybody want to look at any of the homework problems? Again, we're looking at anything that happened between test 2 and problem set 3. Does anybody have questions on any of the problems from any of those assignments?
Yeah, question 14, homework 3.1,
Okay.
quadratic functions homework.
Okay, so homework 3.1, question 14. I'm going to have to move class for a minute. And question 14, right?
Yeah, I just don't know how to do B.
Okay, so question 14, we've got the function f of x equals 2x squared minus 2x. That's on that form, f of x equals ax squared plus bx plus c. And I'm guessing you recognize that since a is 2, it's positive, so it's opening upward. And since it's opening upward, the turning point would be a minimum. Now, for part B, in order to find that minimum value, the first thing we're going to do is that second part, which is where it occurs. And it occurs on the axis of symmetry, which is that line x equals negative b over 2a. So here that would be the negative of b is negative 2 over 2 times a is 2. So that's at the x value of a half. So it occurs when x equals a half, and the minimum value would be what I get when I plug that x value of a half into my function. So f
We've seen hundreds
times a half squared minus 2 times a half, which would be a half minus 1 would be negative 1/2. The minimum value is negative 1/2, and it occurs at x equals 1/2.
so many good kids. You're so talented.
Somebody's got their mic on. Could you please mute if you're not asking a question? I hate asking because I love to hear you folks' voices, but sometimes the background noise gets a little overwhelming. So the domain, because this is a quadratic function, it's a parabola that's opening upward. It goes on in either direction. There's no smallest x value. There's no largest x value. However, because it's a range, we know it has a minimum value. That smallest value is that turning point value, which is -1/2, and then it goes upward from there. Any better?
Yes, thank you.
You're welcome. Good question to ask, because in the other section, I just finished going over their preliminary exam, their problem set with them. And that exact same question was actually on their iteration of that problem test, practice test. Anybody want to look at any others? I'm going to clear that drawing then. No other homework questions? You guys are good? Okay, you guys are great. Then next that I'd like to do is I'd like to kind of just go through and look at a review of what we've done. So for the review, let's add a page. And I think we started looking at functions. And with functions, we talked about the idea of domain and range first. And so I would like anybody, give me a second. I'm thinking that there's a heated discussion going on in the downstairs of my house. Let me shut a door. Can you guys hear that? My husband and daughter talking or no? I apologize for that. So can anybody remember anything at all about what a function is, what the domain of a function is, what the range of a function is?
I mean, like the domain is the x values and the range is the y values.
Beautiful. The domain are the x values, the range are the y values, or the first members and second members. And the function is actually a set of ordered pairs. But what makes it a function is that each member of the domain is paired with exactly one member of the range. So each member of the domain is used only once. So it's a set of ordered pairs in which each first member which is the member of the domain, is paired with exactly one member of the range. We looked at them as ordered pairs. We looked at them as equations in function notation, and we looked at them as graphs. When we looked at them as graphs, does everybody remember that vertical line test? And so if I have something that looks like a parabola, this is a function. It passes the test. Any vertical line will only intersect it in one point. Instead, if I have something that looks like a circle, this is not a function, because we can have a vertical line that crosses in 2 points, saying that whatever this x value is, there are 2 corresponding y values. With functions, we also looked at the idea of function notation. And function notation, we'd have f of x is equal to something. And we said that f of x is just a fancy way of writing y. So if I have something like f of x equals 2x squared plus 3x minus 4, and if I ask for, let's say, f of 1, f of negative 1, and let's say f of x plus 2, can anybody remind me of how to find that? For example, f of 1. What should I do with that number 1? Let me, oh, I didn't want to do that. I wanted to do that and open the chat.
Substitute.
Substitute 1 for x. I put 1 in the x place, so we're going to substitute 1 for x. So that gives me 2 times 1 squared plus 3 times 1 minus 4. So what is that? 2 plus 3 is 5 minus 4 is 1. Be careful when you substitute in negative numbers. If you're using your calculator, make sure you put parentheses around that negative value. And that becomes 2 minus 3 minus 4, or negative 5. And over here, when I've got an algebraic expression in there, instead of just a number, I'm going to think of this function as 2 times what's in the parentheses squared, plus 3 times what's in the parentheses minus 4, thinking of that x is just a placeholder for what's in the parentheses. And so instead of just putting in an x, we're putting in that expression x plus 2. And we're using our order of operations. So first we have to square. And remember, when you square a binomial, you multiply it by itself. You should get a trinomial. And so that would multiply out to x squared plus 4x plus 4. And then we have 3 times the x plus 2 minus 4. Then we'd need to distribute, giving me 2x squared plus 8x plus 8 plus 3x plus 6 minus 4. And then combining like terms, it would be 2x squared plus, let's see, that would give me 11x, and then 14 minus 4 is 10. And then another example of a function type question, which we'll see a little bit later, would be something like, is x squared plus y squared equals 16 a function? And as I look at that, can anybody recognize when both x is squared and y is squared, what would the graph of that equation be when they're both square?
A circle.
It's a circle, beautiful. And since it's a circle, it would fail the vertical line test. And so here the answer is no, it's not a function. So basic function definition-y stuff. Everybody okay? If not, from there we went on to all things linear. And we look at linear functions and some attributes of lines and line segments. And can everybody remember that in order to be a linear function, it's first degree, so that the highest exponent is 1. So we'll just have an x and we'll just have a y. No other exponents on the variables. When we talked about a linear function, the first quality that we talked about was the slope. And we said slope was abbreviated by m. And can anybody remember the formula that we used to find the slope of a line through 2 points?
y2 plus y1 over x2 plus x1.
So close.
Or minuses.
They're minuses. Difference in y's over difference in x's. Beautiful, though. So it's the change in y over the change in x, the rise over the run. And remember, we had said that if slope is positive, it's increasing. If slope is negative, it's decreasing, meaning going down is what I look from left to right. Increase is going up, decrease is going down. If slope equals 0, can anybody remember what that meant about our line? A couple people got it a little mixed up on that last quiz. 0 is horizontal. And 0 would be if I have 0 in the numerator. A couple of people got that mixed up. Instead, if slope is undefined, then I'd have a vertical line. And that undefined slope would be if there's 0 in the denominator. Excuse me. And while we're talking about slope, we had also mentioned the relationship with slope and parallel lines. And parallel lines, we said, had the same or equal slopes. And perpendicular lines. Perpendicular lines, we said that the slopes are negative reciprocals. So if one is A over B, the other would be the opposite, negative. Can flip that fraction, B over A. But we did say there was an exception to that rule. And the exception to that rule said that if I had a horizontal line, and a horizontal line would be an equation where y is equal to a constant. It's perpendicular to a vertical line. Which would be where x is equal to a constant. Everybody with me so far?
Yeah.
If that's all right, and after we did the discussion of slope, we looked at different linear equations. And one which I was surprised a lot of people didn't recognize on that quiz, the one that I think we use most often is the point slope formula. And we use it if we have a point x1, y1, and a slope m. And it's y minus the y value of the point, y minus y1 is equal to the slope, or m, times x minus the x value of the point, x minus x1. And so that was my point slope formula. In addition, next most commonly used is that slope intercept form. And in the slope intercept form, we take that preceding one and just solve for y. it would give us something like y equals mx plus b. And so the slope is m, and the intercept is the y-intercept, so it would be a point of the form 0b. And then we also had that general form. And that general form was something of the form ax plus by plus c equals 0. And what made that one distinct is that the one side was 0. And after we looked a lot at equations of lines and graphed lines using our slope and y-intercept, we then went on and looked at a couple other formulas. One was for the distance between 2 points. And the distance between 2 points turned out to be real large radical. The square root of the entire expression will take the difference in those x values and square it. We'll add to that the difference in the y values squared. And so the distance is the square root of the sum of the difference in the x values squared plus the difference in the y values squared. And also between 2 points, we were asked to find the midpoint. And what strikes me first is that the midpoint is a point. The point has a distinct x value and the distinct y value. Because the midpoint is in the middle, it's halfway between the two x values. That gives me the average of the x values, it's the sum of the x values divided by 2. And all in the same way, the average of the y values, or the sum of the two y values divided by 2. Then from those ideas, distance is something you find between 2 points that lie on a straight line. Midpoint would be in the middle of a line. But from there we went on and we looked at other functions. And actually some non-functions too. So let's just say other equations. And the first was that of a circle. And with the circle, we had the general form, which is x squared plus y squared plus dx plus ey plus f equals 0. And we said that we knew it was a circle if it was second degree in both x and y. Both x and y are squared, and they have the same coefficient. So I can divide out so that they each have a coefficient of 1. That form was interesting, but not real useful. We like better the standard or center radius form. And that came from going through here and completing the square in x and y. And we got x minus h squared plus quantity y minus k squared equals r squared. And we said that hk is the center and r is the radius. And then in answer to that homework question, we also looked at quadratic functions. Oh, I misspelled quadratic. Let's try that again. Quadratic functions. And they were of the form f of x equals ax squared plus bx plus c, or y equals ax squared plus bx plus c, and they're second degree only in x. We had said that if it was in this general form, we had said that if a is positive, we know it opens upward and our turning point is a minimum. We had said that if a is negative, it opens downward and our turning point is a maximum. We had said that the line that goes through the middle, which is the axis of symmetry, turns out to be the line, it's a vertical line, so it's x equals, and it's the ratio negative b over 2a. And then we said for the vertex, we're going to substitute that x value, and we'll find that the max or the minimum occurs at f of that value, negative b over 2a. What we get when we substitute that number in for x. The much more user-friendly form was the vertex form, which was f of x equals a times x minus h quantity squared plus k, which we could get by completing the square, and then use this combined with the idea of transformations to, again, we had said that if a is positive, it opens upward and we have a minimum. If a is negative, it opens downward and we have a maximum. But here, our vertex is the point hk, where h is what we're subtracting from x, and k is what we're adding at the end, so that the axis of symmetry is the line x equals h, and the minimum or the maximum value is that number k. Now, I made that grocery list from my memory, which is a failing thing, a fleeting thing, right? I think that was pretty much everything that we've done since that last test. How does it look? Does it all look familiar?
Yeah, for the most part.
Okay. Can anybody think of anything that I forgot? If this coming test were in class, you would need to know all of those formulas. For this course, on an in-class test, I do not give a formula sheet, because when you move ahead to the trig course and the pre-calculus and the calculus course, you need to know all of these formulas. You need to be able to work with all of these without having to stop and look up a formula. So, but does anybody have questions on any of these? If not, can I leave this page and move on to look at that problem set, that practice test, to give you an idea of what you're going to be looking at?
Yes.
Okay, thank you. So let's look at problem set 3. And so first question asks us to decide if x plus y equals 25 is a function or not. And there's a couple of ways that we can do this. One way is to plug in a whole bunch of numbers for x and see if for each one we only get one single value for y. Another way we can do it is try to picture it. What would the graph of this function be? Of this equation, pardon me. What would the graph of this equation be if there are no exponents on x or y?
A line.
It's a line. And because it has both x and y, it would be a slant line. And so whether it goes up or down, can everybody picture a slant line would pass the test? And so it is a function. So let's look at a what if scenario. What if instead I had x squared plus y minus 2 equals 0? What would the graph of this one be? If only one is square.
An upwards parabola.
It would be a parabola. Before we decide up or down, we'd have to move the y over. But in either case, if it's a parabola, is everybody out right? It would also pass the vertical line test. So it is a function. I think on the preceding pages, we looked at one where both are squared and realized that if it was a circle, it would not pass. Is everybody all right with this question? Can I clear it? Next question then asks us to evaluate the function f of r equals the square root of r plus 6 minus 6. And we want to find f of negative 6. We want to find f of 75. And we want to find f of x minus 6. And so I'm going to shut up and ask you folks to please do each of these and tell me what you get. How did I do? Did everybody get the same? For the first one, did everybody get negative 6? The second, 3. And the third, radical x minus 6. Does anybody need or want more details? Any questions? you return the page?
Yeah.
Sure.
Next question asks you to use the vertical line test to decide whether this is a function or not. And so is this a function?
No.
No, because it passes the vertical line test. The vertical line could intersect in 2 points. Great. That one's almost too easy. Should I take it off the test?
No.
No. Okay. Next one says a company that manufactures bicycles has a fixed cost of $100,000 and it costs $150 to produce each bicycle. The total cost for the company is the sum of its fixed cost and its variable costs. Write the total cost, C, as a function of the number of bicycles it produces, X. Then find and interpret C of 90. And so let's see. C of X. Well, they said the cost is the sum, so we have to add of the fixed costs. That's our 100,000 plus our variable costs. What would vary would be how much it costs depending on the number of bicycles. Does it make sense that if it's $150 per bicycle, that variable would be, cost would be $150 times the number of bicycles? So then to find C of 90, function notation, we're replacing X with 90. And so when we work that out, what are you folks getting? Anybody got an answer yet? Anybody else get 113,500?
Yes, I forgot my mic was muted. I was trying to answer.
Oh, okay, all right, thank you. And so the 90 is the number of bicycles. And so it would cost us that much money to produce 90 bicycles. Just a second, you guys. I'm going to.
Did she do yours?
Mm.
Your crown?
Yeah, I apologize, folks. My daughter came in and hit a vent about something. I'm so sorry. All right. So this question, all right?
Yep.
Okay. Then next one. Use the point slope form of the line satisfying the given conditions. Then use the point slope form of the equation to write the slope intercept form of the equation. So let's see, what conditions do we have to meet? We want it with a slope of 4 passing through the given point. Well, point slope is the y minus the y value is equal to the slope times x minus the x value of the point. So on my point, the y value is 8, y minus 8. The slope is 4, and the x value of the point is -3. Is everybody all right? X minus -3 would be x plus 3. And when they want it in point slope form, that's where we're stopping. And then to put it into slope intercept form, we're going to solve for y. So we get y minus 8 equals distributing 4x plus 12. And then adding 8 to both sides, I'd get y equals 4x plus 20. And so that's my slope intercept form. And again, I was surprised on that last quiz. Some people had this on their tests, but did not say this was the point slope form. Rather, they said that the other was. And then they kind of put in gibberish for the slope intercept form. Y minus the y value is equal to the slope times x minus the x value. That's always going to be your point slope form. This one okay?
Yeah.
Oops. What happened there? Then next, we've got the equation of a line in point slope form and slope intercept form. And we know that it passes through the point 9, 5, and it has an x-intercept of 4. X-intercept of 4. If I try to picture it, that means that this line is crossing my x-axis at 4, which means that it's going through that point 4, 0. X-intercept always has a y value of 0. And now that I've got 2 points, can't I find my slope? So the slope is the difference in the y values over the difference in the x values. So the difference in the y values would be 5 minus 0. The difference in the x values would be 9 minus 4. So 5 over 5 gives me a slope of 1. So now for the point slope, there should be 2 correct answers here for the point slope, depending on which point you use. Point slope is y minus the y value is equal to the slope times x minus the x value. If I use that x-intercept, that would be y minus 0 is equal to 1 times x minus 4. That would be my point slope form. And then solving for y, I would get y equals x minus 4. Slope intercept form. Point slope form could also be y minus 5 is equal to 1 times x minus 9. And when we clearing that up, we would still get that y equals x minus 4. So either one should be acceptable. But be very careful. If they give you the x-intercept, remember the x-intercept always has a y value of 0. And so go ahead and change that into a point with a y value of 0. Any questions on that one? If not, can I clear it and go on to the next? Everybody done?
I'm done.
The next question asks you to write the equation of a line in point slope form and slope intercept form, passing through a point parallel. Now I have to tell you guys in the other section, the test gave me not parallel but perpendicular. So here, let's first look at parallel. And if it's parallel to y equals negative 3x plus 4, we have to remember that parallel means we have an equal slope. To find the slope, we want to solve for y. The x coefficient is the slope, so the slope is -3. And now we're going to use the point slope form, which would be y minus the y value is equal to the slope times x minus the x value, which would be y minus -2 is y plus 2. Because it's parallel, it's the same slope. And it would be x minus the x value, which is x plus 9. And then for slope intercept, we'll go ahead and solve this for y. Y plus 2 equals distributing -3x minus 27. And then subtracting 2, we get y equals -3x minus 31. And again, just in case, if this would have, instead of saying parallel, if this would have said perpendicular, you'd have to remember that for perpendicular, the slope is negative reciprocal. And so instead of a slope of -3, it would be positive 1/3. And so where we had the -3, instead we'd have a positive 1/3. And then we'd have to go ahead and simplify. Is everybody comfortable with both finding a parallel line and also a perpendicular? Again, on the test, these questions are kind of pooled, so some of you might get parallel and some of you might get perpendicular. Is everybody comfortable with both? Any questions? Can I clear this? Next one asks for the slope-intercept equation of the function whose graph satisfies the given conditions. And so over here, it passes through the point -7, -2, and it's perpendicular to the line whose equation is x equals 19. And again, because this is x equals, we know that this is a vertical line. And so perpendicular would be a horizontal line. Horizontal line would have as its equation y equals some number. And if it's going through that point, it would have to be y equals -2. And again, the question on this that I did with the other section was different because we didn't necessarily have horizontal and vertical lines, but rather slant lines. So be able to work with both. Any questions on that one? Am I going too fast or is this all right for you guys?
I'm good.
Then let's clear this and go on to the next. Find the distance between the 2 points. Oh, what fun. Let's see. Distance between 2 points is the square root of the difference in the x values squared plus the difference in the y values squared. So that would be the square root of, let's see, my x values are 3 radical 2 and negative radical 2. So that would be 3 radical 2 minus negative would be plus radical 2 squared plus the difference in the x value. I'm sorry, those are the x values. I apologize. The difference in the y values would be radical 7 minus 4 radical 7 squared. For subtracting, this would give me 4 radical 2 squared. And this would give me negative 3 radical 7 squared. 4 squared is 16. Radical 2 squared is 2. So that's 16 times 2 or 32. Negative 3 squared is 9. Radical 7 squared is 7. 9 times 7 is 63. And so that gives me the square root of 95. Simplify, use radicals as needed. Let's see. 95 is divisible by 5. That's 5 times 19. And since those are both prime, we're going to leave it like that. The radical doesn't simplify. And so now that would be my exact answer. And then to the nearest, I'm going to take my calculator and find the square root of 95 to the nearest 2 decimal places. That would give me 9.75. How is everybody with their distance formula? Any questions? If not, I'm going to clear it and go to the next question. Here we want to find the midpoint. And again, when I think of midpoint, I immediately think it's a point. Point has to have an x value and a y value. Excuse me. The x value is the average of the 2 x values. So x1 plus x2 over 2. The y value is the average of the 2 y values. So y1 plus y2 over 2. And so that gives me negative 5/3 plus negative 13/3 over 2. Negative 18/3 would be negative 6 divided by 2 would be negative 3. The y value would be 2/3 plus negative 14/3 over 2. So that's negative 12/3. Negative 12/3 is negative 4. Divided by 2 is negative 2. And so that would be my midpoint. How's that one? Can I clear it?
Yeah.
Thank you. So then next question. Asks you to write the circle in the given center and radius. And again, for a circle, you have to remember that it's x minus the x value of the center square plus y minus the y value of the center square is equal to the radius squared. So here that would be x minus 0 quantity squared plus y minus 0 quantity squared is equal to my radius 10 squared. And I guess this one we could simplify to x squared plus y squared equals 100. What you need to be able to do is to also work backwards and go from this equation to finding the center and radius. Is everybody all right working both ways? Not hearing any question, I'm going to clear it and go on to the next. This one asks you to find the center and radius, and then graph it and find the domain. And so again, for the center and radius, I'm going to compare it to x minus h squared plus y minus k squared equals r squared. And so where I have x squared plus y squared. Oh, this is the same numbers backwards. So the center is 0, 0, and the radius is 10. So I'd start at the origin and I'd go 10 in each direction. And I could try to wing it, but I'm not real good with that. Instead, I could use that graphing tool, circle graphing tool. I'm going to start at my center, and then I'm going to move out until I get that radius of 10. And doesn't that one look much nicer? In terms of the domain are my x values. My smallest x value is -10. My largest is 10. I hit every number in between. So it would be from -10 to 10, closed interval. For the range are my y values. The smallest y value is -10. The largest y value is 10. And so this one, the range would be from -10 to 10 inclusive. How's that one? Not hearing any questions? I'm going to clear it and look at the next. The next asks you to find the vertex of the parabola defined by the given quadratic. So we've got a quadratic f of x equals 2x squared plus 16x plus 10. That's not in vertex form. If you wanted to, you could complete the square to put it in vertex form. I think it's easier though to use that x equals -b over 2a, which would be -16 over 2 times 2, which would be -16 over 4, or -4. And then for the y value, we'll substitute that in for x. Alpha of -4 would be 2 times -4 squared plus 16 times -4 plus 10, which would be would be positive. 16 times 2 is 32, minus 64 plus 10 would be 42 minus 64 is -22. So our vertex would be the point -4, -22. Is everybody all right with using the -b over 2a to get the x value, and then substituting that into your function to get the corresponding y value? Any questions? If not, can I clear it? And then last question, I've got the function f of x equals -2x squared plus 20x minus 4. And without graphing it, we want to know whether it has a minimum or a maximum value. Well, a is -2, which is less than 0. If it's less than 0, it's opening downward. And if it's opening downward, I would have a maximum. In order to find that maximum, we'd have to find where it occurs first. and it occurs on the axis of symmetry, which is that negative b over 2a, which would be negative 20 over 2 times negative 2. See, negative 20 divided by negative 4 is 5. And the minimum value would be f of 5, which would be negative 2 times 5 squared plus 20 times 5 minus 4, which would be, what is that, negative 50 plus 100 minus 4 would be, I believe, 46. Now for the domain. Because we've got a parabola opening downward, we know that the x values keep going right or left. And so the domain will be all real numbers from negative infinity to infinity. And remember, when we have that infinity, it never equals infinity, so it'll always be an open interval. Now for the range, we know that it has a largest value, which is 46. So it'll be closed at 46. And since it opens downward, it has no smallest value. So it'll be from negative infinity to 46. How'd we do? Any questions on that one? If not, I'm going to clear it. Turn my finger back into a mouse and exit and stop sharing. And ask, what do you folks think of that in terms of being like what your test will be? Everybody all right?
Yeah, not bad.
Okay. Make sure you go through that preliminary exam more than once, because again, some of the questions that I did with the other section were different because they're pooled. So sometimes you'll see parallel, sometimes you'll see perpendicular. Sometimes you'll have questions with points that refer to the x-intercept. You need to put in a y value of 0. Sometimes the y-intercept, you need to put in an x value of 0. Sometimes both. Sometimes with the quadratic functions, it'll be in that vertex form. Sometimes it won't. Sometimes circles might have a center at the origin. Sometimes they won't, and so on. Does anybody have questions about any of this? Does anybody want to look at anything more?
No, have a good day.
Okay, all right. Anybody come in late? I know I let a few people in late and I didn't add you to the attendance, so make sure I get you if you came in late. Jet, were you here when I called the first time?
Yeah, I just couldn't get my mic to work. I don't know what was going on. I joined the class like 5 minutes before even starting.
Okay, gotcha. Anybody else come in late? Elise, were you here at the beginning?
Yeah, I was here. I joined at like 12:29.
I know I let somebody else in and I can't remember who it was. And it looks like they must have left already. So I guess if you don't tell me you're here, I don't know. I'm sorry, Elise. All right. So any questions from anybody?
No, have a nice weekend.
Okay. No, I'll see you on
Wait.
Thursday.
Lol.
Have a nice, no, I won't see you Thursday. I'll see you Wednesday. So have a nice Tuesday. Okay.
You too.
All right. Have a good one. Bye-bye. Elise, you okay, hon?
Yeah, I'm trying to find the leave button.
Okay. I'll just end the meeting then. Bye-bye.
All right, thank you.